In this video, what we're going to discuss is we're going to continue our we're going to continue our journey on proving triangle similarity. Then number 2, after that, we're going to use similarity concept in solving for unknown sides. And after that, number 3 is we're going to solve worded problems or real life problems that involves triangle similarity. So before that, let us recall first the tests which are useful, which we use in proving triangle similarity. The first one is the AA similarity test. It says that if two angles of a triangle are equal to the two corresponding angles of another triangle, then the two triangles are similar. So meaning in this test, we just need to show that the two pairs of corresponding angles, not necessarily three. In SSS similarity test, it says that if the ratios of the corresponding sides of two triangles are equal, then the two triangles are similar. So it's actually the number 2 property of similar figures. Then the third one is the SAS similarity test, SAS. If two ratios of the corresponding sides of two triangles are equal, and the pair of included angles are also equal, then the two triangles are similar. So in this test, we need to emphasize the role of the angle. So if we compare this side to the other side, that's the corresponding sides, first pair of corresponding sides, and we have another pair of corresponding sides there. Therefore, the included angle, which is the angle in the middle for SAS, is this one. So what I'm trying to mean here is that the angle is not just any other angle. It should be the included angle, the angle between the sides that you're trying to compare. Next is the RHS similarity test. Note that RHS similarity test is just used for right triangles. Okay. If the ratios of the hypotenuse and one corresponding sides are equal, and there is a pair of right angles, then the two triangles are similar. Okay. But it is also worthy to note that not all right triangles can be proven using RHS similarity test. Okay, RHS similarity test must satisfy the hypotenuse, one corresponding sides, and pair of right angles. If these conditions are not satisfied, then we cannot use the RHS similarity test. So let's try proving some triangles and show it, prove their similarity. Number 1 here is that we have triangles ABC, and we have a smaller triangle DEC. The given is, the premise is that AB is parallel to DE. The arrows, this one symbolizes parallelism. So as you can see here, when they are parallel, it goes to show that this angle are equal. So we say that angle BAC is equal to angle EDC. Why are they equal? Because they are corresponding angles, and corresponding angles are equal. Meaning, what makes them corresponding angles is that because of the parallelism of AB and DE. So imagine when you have parallel lines cut by a transversal, this will be corresponding angles. And that's what happened to triangle angle BAC and angle EDC. Next is, we can also say that the other pair are also equal. The same reasoning, angle ABC, angle DEC are equal because they are corresponding angles. Okay. Now, since we have already shown two pairs of corresponding angles, okay, we can now conclude that therefore triangle ABC is similar to triangle DEC. Why is that? Because of AA similarity. What does AA similarity says? It says that if you have two pairs of corresponding angles being equal, then the two triangles are equal. Next, here we have triangle PQR. We're going to prove that triangle PQR and triangle STR are similar. And let's specify the given. QR is 2 cm, PR is 3 cm, TR is 6 cm, then SR is 9 cm. Let me just make it clear. So here we can show it using, if we're going to test AA, we cannot use AA similarity test because the given measures are angles. We cannot also use SSS because QP and ST are unknown. There are no indicators that we can compare them. We're going to look at RHS. We cannot also use because these are not right triangles. Therefore, we are left with SAS. Thus, there are two sides given, two corresponding sides, and we can look for that included angle. So from this, we can say that let's try to pair. So the name itself, we can pair it from there. So we can pair the corresponding sides and make a ratio of them. We can do PR and SR. So we say PR is to SR. That's the ratio. The ratio is 3/9. That's 1/3. We have also QR all over TR. That is 2/6. That is also 1/3. So we have shown that the two corresponding sides, their ratios are equal. Meaning we need to look for the included angles. The included angles should be the angles between these sides that we compared. So in this case, the included angles are this one. We can say that they are equal because QRP, angle QRP is equals to angle TRS, or you can say PRQ and SRT. They are equal because, why are they equal? Because they are vertically opposite angles. They are vertically opposite angles. So as you can see in SAS, we take the ratio, we take another ratio of the corresponding sides, and we found out that they are equal. We also look for the included angle, which is this one. So we satisfy that SAS already in this figure. So we can conclude now that triangle PQR is similar to triangle STR. That is by SAS similarity. Okay. Next, in this case, um, let's try to, since these are right triangles, let's try to look if the given measures are, we have right angle, of course, hypotenuse. Yes, the given measures are hypotenuse. Then there's our pair of, there is a pair of sides, which is the BC and the DE. Okay, so what we're trying to prove here is that prove that triangle ABC is similar to triangle ADE. Okay, so from that, let's us show first that there is a pair of right triangles existing. Okay, of course there is angle ABC is equals to angle ADE. They are right angles. That's number one. Next thing is we need to satisfy that the ratio of the hypotenuse. Okay, so in the larger triangle or the smaller triangle, the hypotenuse is in triangle ABC. The hypotenuse is AC, so that's AC. While the hypotenuse for the larger triangle, which is the ADE, is AE. Okay, let's try to find the ratio of that. And AC is 8 cm. AE is 8 plus 2. So that gives us 8 over 10. And that gives us 4/5. Okay. So as you can see, in RHS similarity, we already showed the right angles, the ratio of the hypotenuse. What we're going to show is if the ratio of the remaining side, which is in this figure, we have BC from the smaller triangle, is to DE compared to DE from the larger triangle, and that is 4 over 5. So as you can see, the ratio of the side and the ratio of the hypotenuse are equal, and there is a presence of right angles. Therefore, we can conclude that triangle ABC is similar to triangle ADE. This is by RHS similarity. Okay, that's all for proving triangle similarity. The tip is that you try to match the given measures in the figure in the 4 similarity tests. Okay, if it's not a right triangle, you cannot use RHS. If all three sides are not given, there are no indicators of all the 3 sides, you cannot use SSS. So you just try to match the given problem to the given similarities. Next is solving unknown sides in similar triangles. In this case, in these problems, what we're going to do is we will use the similarity of these triangles to solve for the unknown sides. Number one is we have this one. Triangle ABC is similar with triangle XBY. So the naming, the order of the vertices also indicates the corresponding vertices and corresponding angles, meaning A corresponds to X, B corresponds to B, C corresponds to Y. So in this case, we have the following given. BX is 5 cm, XY is 4 cm, BC is 15 cm, and AC is 10 cm. What we're going to do is find the length of BY, the length of BY. This is the length in question. So what we're going to do is we will look for corresponding sides which the given are already available. So as you can see here, the corresponding sides with available measure is xy and AC. If you're going to look at here, these are corresponding sides. And we can use that to set up our equation. So we say AC, so this is for number 1, AC all over xy. Then the other ratio is that we will use the by, which is the length that we're trying to find. So since by, look at this, xy is in the smaller triangle, by is also in the smaller triangle, so we will put the by here. So the placement of the order of the ratios are very important. So the corresponding side to by is actually BC from the larger triangle. From that. Okay. So from there, sir, why do we try to make AC over xy being equal to BC over by? Again, AC and xy are corresponding sides. BC and by are also corresponding sides. Why are we making equations of the ratios? Because they are already declared as similar triangles. When they are already declared as similar triangles, meaning the properties are already applicable. What are the two properties? The first property is the corresponding angles are equal. Number 2, the ratios of the corresponding sides are also equal. That's where this equation comes from. Okay, from property number 2, because it's already given that these two triangles are similar. So we can use the similarity to set up the equation and set up the equation to find the unknown. So we can now substitute the given values. AC is 10 cm. XY is 4. Then we have BC being 15. And BY, which is our unknown. We can cross multiply or we can get the LCD. So by cross multiplication, we say 10 times BY equal 4 times 15. Divide both sides by 10. Divide both sides by 10. BY is, if we're going to multiply 4 and 15, that's 60 divided by 10, 6 cm. So BY is 6 cm. The same idea with AX. In AX, we will use the same given ratio. The AC and the XY. But this time, what we're going to do is, we cannot use AX because AX is just part of AB. Okay? Note that the AX does not make a side of a triangle. Okay? It's just part of AB. So we cannot use AX in using a ratio, in forming our ratio, because AX clearly does not make up the whole side of triangle ABC. It's just part of AB. So what we're going to do is we will use the AB. Over what corresponds to AB is XB. Okay, so AB, look at this, AC from the larger triangle is to XY from the smaller triangle is equal to AB from the larger triangle 2xb in the smaller triangle. Hopefully you understand why we use AB instead of AX, because AX we have AX does not make up the whole side of triangle ABC. So in this case, what we're going to do is we can substitute AB as AX plus 5. So AB we can substitute with that with AX plus 5. Therefore we can find AX. So AC all over XY, that's AB all over XB. And as we have said, we can replace AB with AX plus 5. So we say AC and from here we can now substitute the available measure AC over XY, that is the same as 10 over 4. AX, that's what we're trying to find. We have XB. XB as 5 cm. So from this we can cross multiply. We have 4 times 10, 5 times 10 equals to 4 times AX plus 5. So we say this is 50. We say this is 4 times AX plus 20. Distributing 4 that. From here we can solve the simple linear equation. Subtracting negative 20, subtracting 20 from both sides, we have remaining as 30 is equals to 4 times AX. Dividing by 4, dividing by 4. We will have AX being 7.5 cm. 30 over 4 is 7.5 cm. So that is the length of our AX. So again, recall that we just use the equality of the ratios in solving for the unknown. Next. So given that ABP is similar to triangle CDP, find the value of X and of Y. So in setting up our, it's given already that they are similar. In setting up our ratios, let's look for the available measures like AB and CD. So we say for letter A, AB over CD is equal to, if we want to look for the X part, which is the BP, that corresponds to DP. So we can substitute now our available measures. AB is 4, CD is 6, BP is X that we are trying to look for, DP is now 3. The same idea, we can cross multiply, so we may not cross multiply 6 and X, we can just cross multiply this. So we have 4 times 3 all over 6 equals X. So X is 4 times 3 is 12 divided by 6, that is 2. Therefore X is just 2. Letter B. We will use the same ratio as AB and CD, that's for convenience. Then we will look for the Y part that we're trying to look and okay. The Y part is in the larger triangle that is same side with CD. So therefore we will put CP here. not in the numerator, because CD from the larger triangle is in the denominator. That's why we need to put also CP in the denominator for the ratio, because it's from the same triangle as CD. And the corresponding side of CP is AP, which is actually 5 cm. So we can use again this ratio 4/6 to solve for our AP, which is 5, and to solve and CP, which is Y. And cross multiply, so we have 4Y, then 30 divided by 4 divided by 4. Y is actually 7.5. That's the value. So that's how you solve for the unknown sides when the two figures are similar. You set up the ratio as equal because that's the property number 2 of similar polygons. Then you manipulate the equation, you can solve for the required. Next is we're going to try some problems involving triangle similarity. We have here, to determine the height AB of a tree, Miguel places a mirror on the ground at E. There, the mirror is in E. From E, he walks backwards to a point D, where he is just able to see the top of the tree in the mirror, CD. FE and AB are CD, FE, and AB are perpendicular to the line DEB, which is the ground. Given that BE is 18 cm, ED is 2.1, rather. And that his eyes at C are 1.4 m above the ground. So this one, that is 1.4. Find the height of the tree. So meaning we are looking for this. Okay, so we say let x be the height of the tree. So this case, we set up the ratios. Okay, we set up the ratios the same as what we did in the previous example in these problems. So we look for the similar corresponding sides with already available measures, and you can see it here. It's the 18 and the 2.1. Okay, so we say 18 all over 2.1 is equals to this ratio and this ratio. Since 18 is from the larger triangle, we will write the x here. That's also from the larger triangle because we let the height of the tree be x. Then since 2.1 is from the smaller triangle, we will also put the 1.4 in the denominator. The same thing, we will multiply and divide by 2.1. So it's like saying 18 times 1.4 divided by 2.1 is just x. So no need to cross multiply the 2.1 to x, because after that, if you're going to multiply 2.1x, you need to divide again by 2.1. So therefore here x is 12 meters. Be careful check if the units are the same, because if the units are not the same, you need to convert one from one unit to the other to make them the same, so that you can set up the equation. So and therefore the height of the tree is actually 12 meters. Okay. Next, a candle is placed 15 cm from a lens and a screen is placed at a distance of x cm from the lens as shown in the diagram. The image of the candle, DE, captured on the screen is inverted and is 3 times the length of the candle. 3 times the length of the candle. Find the value of x. Okay. So what we're going to do is we're going to set up a ratio of first. So imagine that you have this triangle and you have this triangle. Okay. So the corresponding sides are this one. We can set up a ratio for this side, the image of the candle, and the candle itself. Okay. Then that is DE over AC. Okay. So we say DE over AC. We can just say AC, so that the later on the ratio will be emphasized. So AC all over DE. Then we're trying to find the x, which is we will put BD here in the denominator because this one is part of this triangle, the same part where DE comes from. So DE and BD, they are both in the denominators. They are from the same triangle. And AB and AC are in the denominator and numerator, both in numerator because they are from the same triangle as well. So we know that AC and DE, there is no, in the figure, there is no given value for how long is DE and how long is AC. But it tells us that, it says here, the candle, the image of the candle, look at this, which is the DE, is 3 times the length of the candle. Okay? 3 times the length of the candle. Meaning if the candle is 1 cm, this one is 3 cm. If this candle is 2 cm, 3 times of that, therefore this is 6 cm. So there is no apparent value, but we are given the ratio. It says that the image of the candle is 3 times the length of the candle. So meaning we can say, we can let AC as 1 unit, and since what 3 times 1, 3 times of that is 3, so 1/3. So AC, the ratio of AC to DE, the ratio of the length of the candle and the length of its image is 1/3. Okay, the length of the original image is 1/3 of its the length of the candle is 1/3 of its image. Okay, it's 3 times the length. So think of this idea here. So AB is 15. Then BD is, that's what we are trying to look for, that is x cm. We can cross multiply. 1 times x is x, 3 times 15 is 45 cm. Therefore this from the lens to the image, which is the big screen, the distance of that lens and the screen is actually 45 cm. So that's how we use similarity of triangles in worded problems.